that is behind it and bringing in historic context as they come back to. Alright, so we're going to do dollar deals, and we're going to start very much in the concrete display of the concept here, and putting it within a story. So relating to that part of the brain that will connect to stories, be able to connect back to this later once we get more complex. They'll have a deep understanding from this activity. And you want to stay in this activity more than, like longer than you would think. Because to us it seems very simple, but we're really deeply rooting a concept for students. And to us it seems pretty simple, but for them, the coordinate grid, plotting slopes, this is all very abstract and hard to relate to. So we want to make sure that we're developing vocabulary and really looking at the structure in a very simple situation. Okay, so starting where students are comfortable, dollar deals. Raise your hand if you've been to a dollar store or know what it's about. Okay? Even if students haven't been to a dollar store, which is unlikely, they have shopped. They know what shopping is about, pretty basic concept, and they can all connect to it. So, we're going to role play a little bit here. At dollar deals, everything is $1. It's not like Dollar General, where sometimes it's $2 or $5. Dollar deals, it is all $1. No tax, no tricks, just $1 for one item. All right, so we're going to do some shopping. Michelle, I gave her some money. She's going to come on up and do some shopping for me. So here are my items, yes, many of them provided by my son. So you don't have to spend it all. Do we know how much she's going to spend?
No.
Okay. Okay, hold on. So I'm your cashier. So she has one item. She chose the croutons. So then how much does she have to pay me?
$1.
$1. And why?
One is one. Because the item is the same value as $1.
Right. One item costs $1. Go ahead and get one more. Oh, truck. All right, so how much does she owe me? $1 for one item. So then how much was her total? $2 for two items. Okay? Simple concept. Thank you. Okay, so what kind of math model do you have in your head for what we just did? Not an equation. What kind of relationship? 1 to 1. Okay, one item equals $1. Two items equals $2. So this seems like duh, but for students you need to talk this out and make sure they understand that one-to-one correspondence, that one-to-one relationship. Okay, Melissa, come on down. She's going to do some more shopping. Now, before she even comes up here, do we know how many items she's going to buy? No. So that makes her independent. She is wildly independent. We don't know what she's going to do. So our shopper is our independent variable because she can choose how many items she wants to buy, right? So come on up, Melissa. What's she gonna do?
Well, you know what I'll start with.
My fellow Clemson fan. We don't. She's wildly independent.
I'm going shopping now. It's not. And then I'm having a good time this weekend, so I'm gonna
All right, Melissa, how many items did you buy?
I have 5 items.
So then how much, I'm her cashier, how much do I have to charge her?
$5.
No, I'm going to charge her 15. Am I allowed to do that?
Not at the
No.
dollar store.
Because I have rules, right? I'm the cashier, so she bought 5 items. How much do I have to charge her? $5, right? So I am the dependent variable. Hey, Lucy. So why was Melissa the independent variable in this situation? Right. We don't know what she's gonna do. She can choose how many items that she wants to buy. But I'm dependent on Melissa. Why? I have to do $1 per item, and what I charge her depends on how many items she selects to buy. So she gets to decide her number of items, and what I charge her is dependent on what she chooses. So she is independent, and I am dependent on her. Okay, so we're focusing on understanding that vocabulary within a very simple situation, just $1, one item. And the questioning and the role playing with students, you would maybe even do this more, just to really get that understanding deeply rooted. All right, so now let's plot what's going on here. So from the story, now we can show a representation. So we started in the concrete, we acted it out, we talked through it, we developed some vocabulary. Now we're going to move on to showing a representation while continuing to discuss the concept. So if you buy five items, it will cost $5. So how do I plot that? 5 and 5. So I have 5 items. That's going to cost me $5. Remember, when you have an ordered pair, it gives you 2 pieces of information. We have to constantly remind this, say this to students. I have 5 items that cost me $5. $5. That's 2 quantities, 2 pieces of information for every ordered pair. So we have this here. What does it mean when we say this? X has the same value as Y. What if I buy 6 items? $6. What if I buy 10 items? $10. So what does it mean when I say X equals Y? So the number of items is going to equal the cost. What will students maybe struggle with if they have some misconceptions about equality?
It's the same one.
No, it's not the same thing.
It's not the same thing, but they what?
The same value.
Have the same value? Because the number of items, is that the same thing as the cost? No. So again, bringing in that equality, making sure we understand that the values are equal, or they have a relationship of 1 to 1, but they are not the same thing.
Yeah, and so if you think about what we just did with the picture that we showed, you can link that back to your own understanding of if I have, for example, if this were the number of items, my X is the number of items, what do I know about my Y? So, as my number of items increase, the cost is also going to increase, correct? So we're both going up. We have a positive relationship here. But what we know about this specific mathematical sentence is if I get 5 items, it's going to cost me $5. So those quantities, although they represent different things, are going to be equivalent. Does that make sense? So we think about it in the relationship piece, both of our values are going up. And they're going up at the same rate, aren't they? Okay.
So what helps me understand this and may help students is I think of it as one, so X is our number of items. And Y is our cost, total cost. So think $1 times our number of items equals our total cost. Right? Because we're in dollar deals. It only costs $1 per item. But we know with the identity, property, and multiplication, 1 times anything equals itself, right? So do we necessarily need to write that there? No. But within this situation, it has meaning, and it can help with understanding. And we could have a plus 0 as our b, thinking mx plus b equals y. You don't have to write that there, but it will have meaning. We'll talk about that in a little bit. Okay? Who knows what this is called? This. This is our, I don't know, there before this training, because I learned this very procedurally. Here, memorize this, plug and chug, homework's done. This is our identity function. Why do you think it's called that?
Well, the times one will be identity property.
Absolutely. And we have an equivalent relationship. The number of items is equal to the total cost. We have a relationship of 1 to 1. So here, our slope So we start with 5 items, cost $5. What about other shoppers? What if I bought 0 items? I went in, I didn't see anything. How much would it cost me? Nothing. So I would have 0 items, 0 cost. What if I bought 2 items? $2. 5 items is $5. 6 items is, or no, 7 items is $7. So we can create other stories with other shoppers, right? These are the details of our story. This is like mind-blowing to me. So relating back to how we teach reading. Think about how we teach reading with main idea and details. You can totally relate it to this. So these points on our graph, these are like our details. Our main idea is our equation, our x equals y. What is our slope? How much does it go up every time? Every item? 1. Our slope is 1. That's our main idea. We're at dollar deals. 1 item costs $1. Our slope is our cost per item. The shoppers are the details. These are the little stories of different people that come up and buy different amounts of items. But our main idea here is that line, is that equation. Allison, did you want to add anything to that?
No.
I want to make sure I'm doing this justice. Okay.
Okay.
Like I said, I learned this very procedural. Yes.
I had one question about the graph. When you were doing the concrete, you did the vocabulary independent and dependent. However, you went straight to the graphing, and the graph's not labeled. So how do the kids know which one to put where?
Oh, the x-axis and the y-axis?
Yeah.
I
like,
agree, it
where
should
do
be
you-
labeled.
Where do you tie that in?
So
Does that
when
make
you
sense?
when you have a graph, the independent is always going to be on your x, and so we know that as adults, which is why they didn't put it on this graph. But again, we would have this labeled for students. But again, with the graph, that's very symbolic. So we're moving through this really fast. We would spend a lot of time. We would want the kids to come up with, hey, if I buy 3 items, it costs me $3. If I buy 7 items, it costs me. So we would create the story by having the different details, which would be the different kids coming up.
Okay.
That, and ultimately, we would get to plotting those points.
Okay.
Good question.
Is it always X, comma, Y?
Yes,
For ordered pair, yes.
yes. An order pair is always X, comma, Y. And I like how it is labeled here, 5 items, comma, $5. Because a lot of times when I did coordinate grids, it was just 5, comma, 5. So here's relating back to that story, 5 items, comma, $5. Relating back to that context. So it's not just naked numbers, it relates to a situation, bringing that understanding.
I have a question.
Mhm.
Would you ever do the concrete and the graph at the same time? Like, somebody comes up and buys 5 items, now let's do the graph, like,
You
can
know
do
what?
it that way?
We might see that later. So hold off on that question, okay?
Well, I've had this conversation with a lot of people. The 3 stages in that lesson prototype design, they're not in isolation.
Right.
You're not gonna do like concrete, all right, no, we leave that, and then we're totally moving into representation and discussion. They really bleed together, and they blend. And even within that, like I've talked to a lot of people about representations themselves. Even within representations, you have a spectrum. So it may just require at first drawing what you did concretely, and you're relating it to that, and then your representations get more and more sophisticated as you're talking about it, becoming more efficient, and then eventually you lead into the abstract.
Do you
So
remember?
It's all kind of a fluid.
Yeah. Do you remember the Graham Fletcher Get Fletchy video we showed? I think it was day 2 with the multiplication. And a bit, really detailed at first, and ultimately we're just going into the more symbolic. So it's the fluid, the arrows go back and forth on that prototype, so you can go back and forth. But I would say yes, you do, and we can see that. We'll see it in a minute.
Okay, so now we've really stayed in a simple situation to develop some vocabulary and some understanding. So now we're going to move, and again, you would go slower with students, okay? We're adding on a little more complexity with Unit 2, and now we're going to compare dollar deals versus Piggly Wiggly. All right, so if I can have my volunteers return their items, please, so that we have a decent selection for our next shopper. At Piggly Wiggly, there's a bag sale going on, and everything you can fit into a bag will cost $2 per item. So think about dollar deals, and Piggly Wiggly, it's $2 per item. So now think about, how is that going to change and affect our slope? How would that change our graph? How would that change what our wallet looks like? How would that change our decision making when we shop? How would that change the model in your head? Before you guys had 1 equals 1, right? All right, Janie, why don't you come on up and do some shopping for me? And again, Janie, my shopper, is my what variable?
Independent.
Independent. Why is she independent?
She makes the decisions.
Do I know what she's going to do?
No.
Janie is highly unpredictable. She is very independent. I don't know what she's going to do. All right.
Do I have to put them in a bag?
No,
No.
black like you did.
Okay.
The students, you could do that.
Where does that work? And this one too, just in case I like to use it that way.
Okay. So, here, let's check out. When I go beep, how much is this item? $2. All right. This item? And this item. Okay, so I'm going to charge Janie $5. much do I need to charge her? 6, because $2 for this item, $2 for this item, and $2 for this item. So how much is her total cost? $6. Why am I not allowed to charge her 5? That's not the price. I'm the dependent variable. I have a standard, I have a rule that I have to follow. It's $2 per item, 2 to 1. So for students, especially students that need this visual, you can show the $2 to 1 item, concretely. So her total cost then would be $6. Thank you. You can take it.
Is the bag sale part of it important, like later on, are you
That
gonna
confused me
do?
too, the bag sale.
Yeah, are the later on,
Okay,
are you gonna do?
well, because you're
everything?
adults, I skipped it, just for time, but Janie could have put them in a bag.
Well, no, what I'm asking is, was there a time when you were gonna say, okay, everything in the bag is $2, but this didn't fit in the bag, so it's more?
We weren't gonna go there here. No. That would layer on a bit of complexity that we don't wanna take on right now, because we're really just comparing 1 to 1 to 2 to 1. Okay, we're slowly layering on the complexity. Alright, so again, we are moving through this prototype, and our objectives with Unit 2 are talking about coefficient and slope, how does cost affect slope. Why does Puddly Wuggly have a steeper slope? And how do you model Puddly Wuggly? And this is in your notes.
So I think there's some confusion, Lauren, with the language that's being used, so if you'll do that next click. Okay, so this should have been set up before we actually went through the walkthrough. So with this, the Puddly Wuggly Super Day Sale, you're looking, it's called Dollar Deals because there was one store that was similar to like the Dollar Tree, right? 1 to 1, we're all with me, we all follow that? And then you have this new store, and this new store has a different cost per item. The cost per item on today's bag sale is cheaper than normal, and you're going to have $2 per item. All right? So you're looking at 2 independent stores, not one that's saying a bag sale is cheaper than the dollar. It's just cheaper than their normal sales. So I think the language is getting mixed up. Are y'all with me now?
Yeah.
Okay. All right. And we're going to go with that in just a second. Okay.
So
So
2 different stores.
so think about when we did our dollar deals and you guys came up and it was $1 cost, or excuse me, 1 item cost $1. Now with the Pug, for this special price, it's not that rate anymore. Something's changed. Now how does that change impact our picture, our store? Are you with me
Well, it's
now?
still-
I just saw some connections being made.
But it's still the Puddly Wuggly sale.
It is,
Right.
absolutely.
Because later we're gonna go into Puddly Wuggly not having their sale anymore.
Right,
So
but
that's
for
why
right
we
now,
want the
yeah.
bag sale.
I have a-
Okay, so now we're gonna plot the difference,
Yeah.
because we are comparing dollar deals, 1 to 1, to Puddly Wuggly, which is 2 to 1. I wouldn't focus too much on the bag day sale, it's just the 2 to 1. Alright, so what store are my red dots?
$1.
And how do you know that? Because it's 1 to 1. 2 items cost $2. 5 items cost $5. Now Puddly Wuggly, 1 item costs $2. 2 items cost $4. 4 items cost $8. What do you notice by the difference between the slopes and the lines?
Steeper.
Steeper. Why is Puddly Wuggly steeper?
It's more expensive.
Alright, now with your table, draw or write a math model for Puddly Wuggly in the form of equations.
Say one quick thing, and this is not significant, but it could be.
Uh-huh.
If you know
notice your lines on your horizontal axis, you're skipping a line each time, and that is theoretically not correct. When you graph it, the line should be the same distance. Like that, a child is gonna say that slope is 1/2 instead of 1. I mean, I understand, and I don't mean to confuse anybody, but when you start saying, how does it relate to the lines, you're gonna have a child that's gonna go up there and count and notice that there's a line between each number on the horizontal, but not on the vertical.
That's an excellent point.
So I don't know why they did that with that slide.
Yeah. Well, you'll see why in a minute.
Okay.
But y'all, okay. So what I think is happening is we're going really specific into what all of the adults see because we already know how to do this, and what we're trying to focus on is making sense. And so really, truly, I wouldn't even have mentioned the word slope yet, because what we're trying to do is we're trying to point the picture. And so what you're talking about, we're going to see in a minute the reason that they did that. In this case, what have we identified as our X? Our X is our independent, so that was what? The shopper, right? Based upon the number of items that they purchased, right? And then the dependent was our cost. And so what we're trying to have kids see here is that 0 items purchased is 0 items cost regardless of where you are. But as the dollar deals have a 1-to-1 correspondent, this pub does not. We start to see that this line is increasing much more steeper than the previous one. It's kind of flat, right? Versus where my pug is getting steeper. And so what we're seeing here is that for every item that is purchased, there's a greater change that's taking place from one store to the other. I wouldn't even bring in the word slope yet, because I want the kids to see the picture. Okay?
Okay. So I'm gonna need your help with that because my notes are telling me something very different.
Yeah. But it's gonna, what we're talking about here helps them see that. So go back to what you just clicked. So the discussion of the slope is what we're focused on. The slope, which is the steepness. And so a kid might say, hey, slope, because they're gonna they've heard that from their older brother or their older sister or somebody, and they're gonna pull it into context. So again, what does that mean? What does the slope mean? It means the steepness of a line. And what's steeper? What's steeper from one store to the other? The cost per item. That's when we get into slope.
So the relationship of just the cost of item goes up, you're going to have a steeper increase in your total
Cost per item.
All right, so now unit 3. I'm sorry, I don't want to confuse you. We're going to layer on. We're going to move away from dollar deals, but we still have that understanding. And we're going to compare Puddly Wuggly to Fancy.
And again, these are days. Like, we're not doing this all in one level with kids. These are days that we would, we make a big deal of it. Like, I have my Walmart greeter jacket on and cash register, and we play store, basically. Okay? And we have major discussions about what is transpiring. But over those days, like Lauren's saying, the unit 3, we're keeping with the same story. So kids aren't having to jump from one context to the other. The story's progressing as the math is also progressing. So 2 different stores.
All right, so now we're going to compare Puddly Wuggly and Fancy Food. But to reiterate, what is the only thing we're really comparing between these stores? Cost per item.
Right.
Is that the only factor that you consider when you're deciding where to shop? No, there are lots of other factors. But it's important to point out that we are only comparing, at this point, cost per item, right? All right, so our objectives have changed a little bit because we're increasing our complexity. All right, so Puddly Wuggly, no longer the bag sale, and now it's $2. Puddly Wuggly is how much per item? $2.50. Fancy Foods is $4. Alright, so think about those relationships. And we move, we would obviously with students work that out, talk about those relationships, about those comparisons, and then move towards representing those in a T-chart and on the Cartesian plane. And as mathematicians, sometimes the T-chart would be helpful as a representation, but which one can you compare the slopes easier? The Cartesian plane. So there's different visuals that we can use based on how we want to analyze the relationship or the comparison. Alright, so which one has the steeper slope, the steeper line? Fancy Foods. To us, duh, that's obvious, but to students, you're really honing in this understanding of the cost of per item goes up, the steeper the line. Before, Puddly Wuggly had the steeper line, but now we bring in Fancy Foods, it's $4 per item, so Fancy Foods has a steeper line. Okay, so right now we're still only analyzing what per store?
Price.
Cost per item. Alright, now we're going to add on another layer of complexity. Going to Unit 4, we're going to explore the idea of the constant. And again, we would not talk to students about that terminology yet, but we're just adding in something else to consider. And in this case, we're going to talk about travel costs. So again, our objectives, we're getting a little more complex, and we're going to discuss how adding in that travel cost is going to change our comparison. Because we're deeply rooted in item costs now. We understand that because we've done several layers of that. So now we can add on the travel cost. Can I have 2 volunteers? Anybody?
There's one.
Come on up.
Do you have your cell phones with you? If you'll bring your cell phone up.
Oh, gotcha. Where'd you put the, where'd you put
I need one more volunteer. No.
Uh-huh. Oh, sorry.
What was the question?
Why is it important to say cost per item instead of price?
We'll talk about that in a minute. Okay.
Mm-hmm.
Because I was waiting for somebody to ask that question. Thank you.
Teacher 1 and teacher 2. Alright, so these 2 teachers are talking on the phone. One is going to be shopping at Puddly Wuggly, and one is going to be shopping at Fancy Foods. Concrete, in our lesson progression, in our prototype, concrete doesn't always mean having items or manipulatives or base 10 blocks. Having a skit where you act out a situation, that's also a concrete experience. Okay, we're bringing it down to real life. We've got real people talking through a real life situation. Okay? All right, go for it.
There's no way you will be able to shop cheaper than me with that ridiculous car of yours. What does it get, 7 miles to the gallon? That's unbelievable. The Puddly Wuggly is 10 miles away. Round trip, that's 20 miles. You will spend $9 on gas just driving back and forth to the Puddly Wuggly. What a waste of money. I'd rather stay here and walk next door to the Fancy Foods.
You might be right, but I think I'll save money at Puddly. I mean, the prices are so much cheaper. I've got to win.
Are you there yet? Okay, I've got my first item. It cost me $4. What about you?
Well, you were right. I did the math on it, and I'm going to need $9 in gas. But my first $2.50.
Okay, I'm gonna stop you right there. Look in your notes page, and you have a coordinate grid, and we are going to plot the cost of their items as we go through this year. So, let's discuss some things here. Who is going to Puddly Wuggly? Puddly Wuggly, how much is it gonna cost you to go there?
$2.50 an item.
Per item. Do you have any other additional cost?
I'll spend $9 on gas.
Okay, so before she even buys any item, just to go to the store, how much does it cost her? $9. So she buys 0 items, how much does it cost her? $9. So do you see how this is getting more complex? We're not just talking item cost. Now, with 0 items, it automatically costs her $9. Now, teacher 1, you're going to Fancy Foods, okay? And what does it cost you just to get to the store?
Nothing, taking a walk.
She walked. It's next door. So what does it cost her? 0. Nothing. So she buys 0 items. How much does it cost her? $0. So do you see we have 2 different starting points. This is a big concept that we're working on right here. These 2 different starting points. So then you could even have students make predictions about who do you think is going to win? Who do you think is going to have to pay more based on these starting points? They're probably going to think this one that had to pay $9 to drive there. Okay, so your first items. Puddly Wuggly, how much was your first item?
$2.50.
$2.50. So we started at $9. Where would we plot her first item cost? $9 plus $2.50. $11.50? All right, go ahead and plot it.
And again, we're adults. We know you're adults. That's why we have different scales for the X and the Y. We want to show the progression.
That's right, you have to reason with where's your 1150 on your Y scale. Fancy Foods, how much, I should have started with that one because that's easier. Fancy Foods, how much does your first item cost? $4. Because I should have started with that one because that one's easier. Except you have to figure out where would that 4 lie on your Y axis. So right now, comparing buying one item, Fancy Foods is at $4. One item at Puddly Wuggly in this situation is $11.50. So who's winning so far? Fancy Foods. Okay?
Huh, that means you've already spent $11.50. You are in trouble. I've got another item, and now I'm still only at $8.
Still not a good price. I see what you mean. I just picked up my second item. Let's see, that's 2 times $2.50 is $5 plus that darn $9 for gas. I'm up to $14.
All right, go ahead and plot their second item. Fancy Foods, we buy another item, cost per item is $4. So we went from one item at $4 to 2 items at $8. What about Puddly Wuggly? We add on another $2.50. And we're at $14. Who's still winning? Fancy Foods. Go ahead.
I'm loving Fancy Foods. You know they don't use any growth hormone in their milk here? I'm loving life. Okay, my third item gets me up to 4 times $3, or $4 times 3 items equals $12.
Great vocabulary.
Well, maybe I should give up. I'm still ahead of your cost. I'm at $7.50 plus that $9. So I'm at $16.
$9.50. What were you at again? $12? Uncooked. No pun intended.
All right, go ahead and plot your third item. And again, you're adults, so I'm just going to have you go ahead and plot it. With students, we would talk through it. All right, so who's still winning? Fancy Foods.
Not by as much.
Ah, not by as much. The lines, the points are getting closer. Wow. Okay, continue.
Don't feel too bad. You might as well keep track and get something done. I'm up to 4 items now, and that's $16. Let's see. For me, 4 items cost, let's see, what is it? 4 times $2.50? That's $10. Plus that dang $9. You know, I'm really starting to resent that guzzling monster. That's $19 for me.
All right, go ahead and plot the fourth item. What do we notice?
Who's closer?
It's getting closer. Who's still winning? The lower total cost, Fancy Foods. But we're getting closer. All right, continue.
I've got 5 items now, still cruising here, just $20. Life is good. Yeah. I've got 5 items too, and I'm at 5 items times $2.50 is $12.50, plus 9 is $21.50.
Okay. Go ahead and plot the fifth item. Who's still winning? Fancy Foods. What do we notice? They're getting very close. What do you predict may happen when they buy their 6th item? All right, go ahead.
Well, I'm almost done. I'm just going to pick up a few more items. I'm getting item number 6 here, some delicious garbanzo beans. For $4 more, I'm at $24. Alright, those beans sound good. And I guess I give up. Let me see, I'll get these green beans for $2.50 more, and that puts me at $15 plus $9. That's $24. What did you say? $24? That's impossible. That's what 6 items cost for me. How did that happen? Gosh, I know. I mean, I teach algebra, but I don't know anything about grocery shopping.
All right, plot the 6th item. What do you notice? It's the same. So those lines are meeting. So when they each buy 6 items, what do we know? Same total cost. Okay, continue.
I'm nervous about this, but let's see what happens when we buy 1 more item. Okay, I'm going to be at 7 items, that's $4. 7 items times $4, that's 28 total dollars. What about you? 7 items times $2.50. I'll use that distributive property to figure this out in my head. 7 times $2 is 14, plus 7 times 50 cents is $3.50. So my groceries are $17.50, plus that constant nagging $9 for gas. That's $26.50 for me. Hey, that's cheaper than you. That's awesome. Let's keep shopping.
All right, let's plot the 7th item. And don't you love how it's scripted as plus that constant nagging $9 for gas? All right, go ahead and finish it up.
You know, I don't like what's happening here. I think I'm going to check out. I should have quit while I was ahead. Enjoy your green beans. Enjoy your bovine growth hormone-free milk. See you back at school.
Very nice. Lovely expression.
Y'all can get something out of the prize box. Thanks.
Imagine kids doing that skit. Do you think they would enjoy it? Absolutely. There were a lot of calculations that they did in their head that you could definitely work out or show on the board or have students work out, take it a little slower to verify those calculations. Who ultimately won if they bought 7 items? Puddly Wubbly, but she had to pay $9 for gas.
But if I had a little shopping to do, I'd go fancy foods, and have a lot to do.
Ooh, say that louder.
If I had a little shopping to do, I'd go to fancy foods, but if I had a lot to do, I'd go to Puddly Wubbly.
So is there kind of one correct answer here of where to go? So here's where your questioning becomes really intentional. When would it be better to go to Fancy Foods versus Puddly Wubbly? Like Danny just said, if maybe you only wanted to pick up a few items, when would be good to go to Puddly Wubbly?
Buy the week groceries for the week.
What if it was raining outside? Amazon. Is cost per item the only thing we consider when we go shopping? No. And if you wanted to, you could introduce the y-intercept and talking about the constant here, and that's what our gas was. That was our constant, where it's sometimes called constant, sometimes called y-intercept. Why is it called y-intercept? That +9.
Because of this starting the intercept of the.
That's what I thought at first, because it's eventually going to intersect with the other one, but no.
What was your question?
Why is it called the y-intercept?
Where your values cross the y-axis.
It's where that value crosses the y-axis. Because we had to start at 9.
Also known as your starting point.
For this situation.
Yes. This is all living in this situation. Because we're developing all these concepts within this context.
Can you say that again?
So,
Why is it called y-intercept?
because it is where it is crossing the y-axis. See how we start at 9 because of that gas money? Okay, so I have a question for Allison, because I don't want to move ahead too fast. Should we be working with equations now? Writing out equations? Okay.
So it showed in the model.
Say that again?
Showed in the model. The next one.
Okay. So with your table, see if you can figure out the equation for Puddly Wubbly versus Fancy Foods. You can use your graph.
From that data, it's easier for kids if I show them. Just writing it. If you look at the picture, it's easier sometimes to get the equation because look at the picture. So we got what does it cost plus what it took to get there. You see what I'm saying? So, but I think that's where the just the intersect. And for this, it's actually the y-intercept would be where when I buy nothing, what does it cost? It should show up as that there. I buy nothing. Cost the car, not the walker. That's your.
For Puddly Wubbly, 9 plus
You buy nothing. What's it cost? In this scenario.
What scenario would it not do?
Well, like there was tax cost.
Yeah. Well, if there's tax at only one store.
Still would, if you cost nothing, it still wouldn't be.
Right.
But if you're not talking about, talking about time or something. So this scenario is actually why you're saying that. Let's say to refer to slope and do equations.
Did they even know how to, even know how to set it up?
You're setting it up with your relationship. I didn't know it was them.
Oh, it's okay. No, yes. Friday. Saturday. And all
Alright, about one more minute. Okay.
I kind of want to wrap this up. You want to trade off and then you can get it. You know what I mean? I didn't get the shelf for a while.
Okay, let's talk about these equations. I was talking with Allison because I am so deeply rooted in show the format and then have them figure it out from there. And because I'm so deeply rooted in you kind of show what it's going to look like and then you guys just figure out the little fine points of it. When you start with the reasoning and looking at the picture of the graph, you guys can come up with the equation yourselves. I'm like, are you sure? And I don't, just like we don't give kids enough credit. With just reasoning through this and looking at the pictures and the knowledge in the graph, we can come up with what the equation should look like ourselves. All right, so let's look at Puggly Wuggly. We have this visual represents the cost per item, and what does this represent? The travel costs are $9 for gas to get there. So with students, these visuals help. So we're taking kind of a representation into the abstract equation. So my total, well, there's a few different ways you could write this. Who would like to walk me through, brave soul, would like to walk me through how they wrote it out? Thank you.
2.5x plus 9 equals y.
Okay, so talk to me about the meaning, what all those.
So the 2.5 is the $2.50 per item.
So we have $2.50 per item, and how do we represent our item?
The x.
Our x, because we don't know how many items, right? Okay.
And then plus the $9 for the gas.
Okay, and that will always be $9. That is constant, it doesn't change, it's always going to cost $9. make sense of it and relating it to the context. Did anyone have it represented differently? Okay, so this is Puddly Wuggly. Alright, what about fancy foods? Okay, 4x, what does that mean? Okay, equals total cost. Does anyone have anything different?
She said plus 0, which helped me in my head.
Why?
Well, we were just talking about the fixed cost component, and there wasn't a fixed cost, because it didn't cost her anything to draft for her.
I'm actually gonna rewrite it so it mirrors what I have here. Right here. So 4x plus 0 equals y. Why would it be important with students to have that plus 0 there?
And you're comparing the same.
Well,
And I know
especially,
there's still a constant. Like the constant there is 0, but there's still one there.
And if you're comparing it to the picture, it's nice to put that the 0 there so they see that if you walk, you're not costing it, or you're not spending anything.
Excellent point. So we have our total cost per item, and then what, we just skipped over this? It's representing what this means. There was no travel cost because I walked there. But within our situation, it has a lot of meaning to put that in there. We know because of the addition property, the identity property of addition, that do we need to have that there? Does it change the value? No, but within our situation, it has meaning. And if you don't put that there, some students may get confused without that there. Because we have this plus 9 here, we don't have anything here, wait a minute. Okay, but this is the gas money. And it's 0 because I walked there. So it's $0. Okay, so again, relating it to that meaning, because we just layered on this constant. So we want to make sure we really understand the role that that has in this scenario. Questions here? Do you see how we're very gradually layering on more complexity? Alright, and so then our main idea is our equations. Travel cost plus cost per item, Puddly Wuggly versus fancy foods. That's our main idea. And then our details are our number of items and how much that would cost to eat. Showed in T-chart or on important grids to really understand that comparison. Okay, so now we're going to move on to another scenario. Same idea, but two different shoppers. So we're going to explore another concept, but switch it up a little bit. So we have Jen and Jermaine. They had a little argument about shopping. Jen said that she can shop for things cheaper than Jermaine because guys don't know how to shop. Jermaine thought that was ridiculous and challenged her to a shopping match. "You're on," she said. "Great," said Jermaine. "Save your receipt and you need to include the cost of travel to get to the school." Jen agreed to these conditions and they were ready to go. So we have a challenge here, kind of like teacher 1 versus teacher 2. So we're relating to that, but now it's going to be a little more independent because I'm going to have you guys kind of go through this scenario and figure out who won the argument and what their equations would be. Okay? So Allison brought you the details. And I'm going to give you about 5 minutes to figure out who won, why, what would their equations be, what would their slope be, and what else do you notice? Go for it.
I'll pass out a
stopping and starting? I've hit an hour, but
So the equation for that one would be 2 plus 3 y.
I can if I need to. Or she can just pass it.
Right?
Lots to reflect on.
So she spent $2 no matter what. Just getting there. Jermaine knew about the Ugly vaccine too, but he didn't drive the train. Took the bus and it cost him $150. So his constant is $150 plus 2x. That's probably what we Jermaine. Are they going to the same place? Same place. So it's still the same $2 per highway.
And then once I fully implement, see, we're just doing one component, and then we're gonna. So then, once I fully implement it, then we'll switch. So that's good. But again, we should have a universal screen, because then we can say a low score on this. Here are the interventions a low score. So it's going to facilitate that intervention bank that they want. When we all have different screeners, it's going to be hard to organize a good system to address it. Well, they buy the but it doesn't say here.
Because they have to be the same clothes. I'm sitting there like, what is this? Yes, because the two, yeah.
So like they're always riding right up together.
Yeah.
They're never gonna cross because they have the same seats, the same cots.
So
He wins because he's always gonna take them.
yes, so, yeah.
Alright, about 1 more minute. Again, I'm going way faster than you would with students.
Well, the intent is not the product. The intent is the reasoning. So it's okay to go a little bit faster because you're using the reasoning to figure this out.
And a lot of you, I've already heard you work through the reasoning. having the graph and everything filled out is okay, you don't get it completely there.
No, you're fine.
Alright, 4, 3, you're not completely done filling out the graph, that's fine. We're just gonna talk about your reasoning. 2, 1, 0, okay. Jen and Jermaine. Alright. Who can give me Jen's equation? Of course, where did I carry things around with me and let them down. Here it is. Alright. What's Jen's equation? Tell me why and what it means.
2x plus 2 equals 1.
Alright, what does it mean? That's just a whole bunch of symbols and numbers.
The 2 is $2 for each item she's gonna get. The X is the item she gets. Plus the 2 is the $2 gas that she had to start with. The Y is the total cost.
Did anyone get anything different? Okay? Jermaine.
I have a question.
Mhm.
Did Jermaine pay $150 on the bus both ways?
Round trip.
Well, yeah, we'll say round trip.
Then it would be 2x plus 1.5 equals what?
What is the X
First
represent?
number of items.
Plus what?
1.5, which is in bus fare.
1.5, which, or with students, I would probably do 150.
Okay.
Which is not gas money, that's bus. So he was sneaky. What did he do? He didn't take that truck that Jen was counting on. He took the bus, which was cheaper. Alright, and then equals Y, which is our
Total cost.
total cost. Okay, so you may have graphed it, or you may have just discussed it, but what do you notice?
His total cost is always gonna be 56 smaller than hers as long as they buy the same number of items.
What is the same in both of our equations? Or what's the same and what's different?
The cost what?
Cost per item is the same. So if our cost per item is the same, then what are we focusing on when we're comparing?
How much it took to get there.
Their travel costs. So what's the difference there? Who wins there? Jermaine. Okay, so if we plot that on the graph, what does it look like? What do those lines look like?
They have the same slope.
They have the same slope, but do they start at the same point? No. Is there a graph of this? Yeah. Do they start at the same point? No. They start at, and if I was even doing this in a classroom, I would have this larger so you could really see that they started at 2 different points. So Jermaine starts lower than Jen. And Are they ever going to cross?
No,
Why?
because they're spending the same amount per item, and they also had their determined amounts that they spent for gas.
But that assumes that they both buy the same number of items. If Jermaine buys one more than Jen, then it might make them cross.
They still won't cross, they'll just stop.
Will they cross?
No. No.
What'd you say?
Well, I mean, even if Jermaine buys 15 items and Jen buys 12 items, they won't ever cross, they just stop. Because their slip is the same.
Your initial thing that you stated at the very beginning said that Jen said that she could shop for things cheaper. It didn't even tell us how many items she bought. She just basically says, I can shop cheaper than you. And
If I'm a better shopper, girls know
Right.
how to shop.
So based on our graph that we've created, based on our equations, she is not cheaper because her numbers are higher than his. It doesn't matter how many items they buy. She's always more expensive when you compare it.
So always going back to that question of what were we asking? And can you truly compare if you have different numbers of items?
No.
No. But like you said, is she a better shopper? With this situation,
Seems
no.
like the same shopper.
They're buying the same thing in the same store.
They're buying the same things at the same store, exactly.
They said
So really the only difference is the cost it took them to get there. She was banking on him taking his truck.
That's why we want to send them.
And what kind of lines do we have here? Parallel. And why are they parallel?
They never intersect.
They're never going to intersect. One may stop, like, we had a good point here, one may stop if they have different numbers of items, but they'll still never cross. So see how we're bringing out that word parallel, that vocabulary within context? Any questions about Jen and Jermaine? Did you see how this was set up intentionally to focus on the constant? When we have the same item cost, what does it mean if we just did the constant? Before we had a 0 constant versus the $9, and now we had two different ones. So gradually building and layering on complexity.